Welcome to the Johns Hopkins Women's Health Podcast, A Woman's Journey. Insights that matter. I'm Kelly Gear-Ripken, and I invite you to listen to Johns Hopkins specialists discuss the latest topics in women's health. Now here's your host, Lily Shockney.
Hi, this is Lily Shockney from A Woman's Journey at Johns Hopkins, and this is our podcast, Healthy Insights That Matter. With every fall comes a new flu vaccine. As we age, vaccines become an increasingly important tool to keep us healthy and avoid unnecessary illnesses. Today, I will be joined with infectious disease expert Dr. Anna Durbin, whose primary faculty appointment is in the Division of Global Disease Epidemiology and Control in the Department of International Health at Johns Hopkins Bloomberg School of Public Health. She also has a joint appointment at the Johns Hopkins University School of Medicine. So welcome, Dr. Durbin.
Thank you very much. It's really my pleasure to be here.
So at the start of this discussion, I just want to point out that scheduling of vaccines is truly individualized and should be managed by an individual's primary care physician, not to imply that the PCP is giving the patient the vaccine, but certainly should be expert in knowing which vaccines are the key ones for that patient to have. Dr. Durbin, are people generally compliant in taking vaccines?
I would say overall, not as compliant as we would like them to be. Even when we look, for instance, at how many people get the flu vaccine every year, it's well below the numbers that we would like to see, which is unfortunate. I do think, however, we're trying to make getting a vaccine more convenient. So instead of, for instance, for flu vaccines and for COVID vaccines, instead of having to go to your physician's office for a vaccine, you can schedule that really in the community pretty easily. And I'm hopeful that that will help improve our compliance for vaccines, because I do think making them more convenient and easier to get will be helpful.
Absolutely. Access is a barrier for some people, but they probably pick up their prescriptions in a pharmacy, and more than likely that pharmacy has the vaccines that they in fact actually need. What are the types of vaccines? And I'm asking that not in looking at what kind of virus do they cover, because we'll talk about that in a few minutes, but such as a live strain or mRNA or even attenuated. Can you explain those three terms?
Absolutely. And I'm glad you brought that up, because we've had really great progress in terms of what we call vaccine platforms, which is what you're talking about. How is the vaccine? What is the vaccine based on? And our earliest vaccines were what we call live attenuated vaccines, meaning that they're a live, usually virus, that's been weakened. And when we think of that, we think of, for instance, the measles, mumps, rubella vaccine. We once again have a live attenuated influenza vaccine, but that's really only recommended for children. That's not recommended for adults. What we like about live attenuated vaccines is that they induce what we call our immune response, very similar to if you're exposed to the natural pathogen. So you get your full armamentarium, I would say, of an immune response with these live vaccines, but they do tend to have more side effects and can't be given to everybody. So for instance, they can't be given to pregnant women in general. They can't be given to people who are immunocompromised, because we're concerned that in immunocompromised people, the immune system isn't strong enough to completely neutralize the virus or control the virus, so that they may get sicker with the live attenuated vaccine. So they're not recommended for people who are immunocompromised.
Can you give some examples of individuals then that probably would not? I'm thinking about patients getting cancer treatments.
Sure. People who, for instance, have malignancies and may be on chemotherapy that affects their immune system. People who have natural immunodeficiencies, they don't make good antibodies, or they don't make good what we call T cell responses. In the days before good antiretroviral therapy, people who were living with HIV would often become very immunocompromised because they couldn't fight the virus. Luckily, we're seeing that less and less with the wonderful treatment that we now have for people living with HIV. But generally, it's people who are on different therapies. And we're seeing a real expansion of that with the monoclonal antibody therapies that we're seeing for people who have autoimmune diseases. So we see that with rheumatoid arthritis, with sarcoidosis, with different autoimmune diseases. The treatments that we give suppress that immune response. And so those people may not be candidates for live attenuated vaccines.
In the case of the flu vaccine, Is it true that the original yearly dose is predicted based on the initial rollout that happens with the flu so that later the vaccine gets tweaked a little bit? Is that right?
Yeah, so what happens is we have in the Southern Hemisphere, they have their flu season during our summer. So the seasons are flipped. So we take the data from their flu season, which generally is during our summer, and there's a big meeting at the World Health Organization in Geneva, and they look to see what flu strains were circulating, which viruses were dominant. And then they hold a meeting and they make their recommendation about what flu strains are going to be incorporated in the vaccine. Then as we get more data, the FDA has a meeting generally in the very early spring, and they review all those data and they review WHO's recommendation, and then they come up with a recommendation of what flu strains should be included. And generally, it's pretty much the same. But based on that, that information is given to the manufacturers, and then the manufacturers make the vaccine that they hope will target the most common flu strains that are circulating. Sometimes we have a mismatch because a new strain will come up between the time the recommendation is made and the time the vaccine is available.
I guess then this is also important to know for people that do a lot of traveling, because they might be assuming, oh, I'm going there in July, way ahead of the flu season, so I don't have to worry while I'm there, when perhaps they should be worrying about the flu, but may not be in a situation to have it be accessible to get the vaccine here.
That's very true. If you're traveling to South America in July, August, that's the height of their winter. So that is something to keep in mind. And unfortunately, it would be very unlikely that they would be able to get a flu vaccine here because it might be out of season.
Right. When is the best time to get your annual flu vaccine here in the States?
That is a great question. And it may differ year to year. What we try to do is try to see, okay, when are we starting to see flu cases? I generally like to get vaccinated early October because we know that flu cases generally are picking up November, December, January, and then I should have adequate protection through that time point. I do want to make the case, though, because I think there's a bit of a misconception even around vaccines in general. So I always say vaccines are not designed to prevent infection. Vaccines are designed to make sure that you don't get really sick or, potentially even be hospitalized or die from an illness. They may not prevent you from getting infected, but they will make that infection much, much more milder, and prevent you from getting sick. For flu vaccine, I try to get my vaccine early to mid-October. It's before the height of the flu season. Now, we did have an unusual occurrence of the H1N1 when it first came out many years ago, where we saw cases over the summer. But that's very unusual. Generally, as I said, where we see influenza cases is really in winter, so late fall, winter through about February, March.
Is there an alternative to vaccines for those that may be allergic to some of the components of the vaccine?
The nice thing is that we now have different types of vaccines. So the original flu vaccines, the way they're made is we pick a strain of wild type influenza, then it's grown in eggs, and then it's inactivated, broken up, and given as a vaccine. So we used to have warnings around egg allergy. Now, even that has evolved. What we recommend is what is that allergy to eggs? Unless it's severe anaphylaxis, where your throat swells up, you can't breathe. Generally, other reactions that are really more mild may not exclude you from getting an egg-grown flu vaccine. But we also have a vaccine that's grown not in eggs, but another what we call tissue culture medium. So if you have an egg allergy, that's something that you can let your physician know there's a different type of vaccine that isn't grown in eggs that may be more appropriate for you. Most people will be able to take a flu vaccine of some sort if you have had a severe reaction and may not qualify for a flu vaccine. If you think you're going to be exposed or you were exposed to flu, we can give a medication for that, but it's really best to be vaccinated. And there's enough different vaccines out there that in all likelihood, you can be vaccinated. There is a very rare reported side effect to some flu vaccines called Guillain-Barré syndrome. And it's important, again, to have that discussion with your doctor, because having Guillain-Barré in and of itself doesn't mean you can't get the flu vaccine. It's a discussion you want to have with your physician about, when did you have Guillain-Barré? Was it around a previous flu vaccine or not? That sort of thing. But in general, most people do qualify for the flu vaccine.
I'm curious to know why and how was it discovered that eggs were the right thing to use to
This
do
is so interesting. So this is how we make a lot of vaccines. First of all, birds are the major source of flu viruses. And that's where we get a lot of our flu viruses, is from birds. And then these birds mingle with pigs or mingle with humans and things like that. But, it's experimentation. Sometimes we grow them in different tissue sources to see if we can make them attenuated or weakened, looking for a live attenuated flu virus. But we found that these are a good source to grow and also meet our regulatory requirements. So there's many different regulatory requirements around all vaccine production. Once you have what we call a qualified source of manufacturing, to change that is a big hurdle. And it took a long time before we could have a flu vaccine that is what we call tissue culture grown as opposed to egg grown. It was trial and error, and then we developed a manufacturing process around that. And the source of the eggs for which we grow these vaccines is essentially top secret. We don't want anyone to know, because we want to make sure that nothing happens to that supply.
I was going to ask you. Now I won't.
Yep, it's top secret information.
Extra special top secret. Oh, well, that's fascinating. I know our listeners are intrigued by that, just as I am. So I got my flu vaccine the last week in September, and I got it at CVS. I made my appointment online in a matter of seconds. And in doing so, there was no waiting. It was just walked on up and handed them the paper I printed off of my printer and got the shot and was good to go. I hope that other people are taking advantage of their local pharmacies, Rite Aid, Walgreens, they all have this. So does Walmart. I didn't even know Walmart had a pharmacy until they sent me a advertisement.
And some grocery stores, some grocery store pharmacies.
Yes. You're absolutely right. Weiss is offering them and has big signage outside of the building for even go in. Have you gotten your flu shot and COVID shot yet? Is this banner that's out there, which is pretty terrific. And most of these places will also allow walk-ins. So if you don't know how to do things online, or you just feel like that's intimidating, my husband's in that group. He only uses the computer to play one game on it. He have email. He doesn't know how to open anything, but just click on that one thing I have on there for him. When I told him, I said, I've registered us online, and he went, what do I do when you're not here? And I said, I guess you're going to call her daughter. I don't know. Thought, oh, gracious sakes. Just like our previous years, certainly the last few years, we have been dealing with COVID in a rather major way. Most people are going to be due to be getting their COVID booster. And I also got my COVID booster at the same time that I got my flu shot. I actually had read online in a medical journal that it was helpful to get the two done on the same day. It did not imply, though I've been asked this question by friends that I know, they said, well, is it in one big syringe? And I go, no, they're not mixing them. That's not a good idea, but you're getting it at the same time, and it's going to travel through your body, etc. I'm assuming that you would recommend getting those two vaccines at the same time as well?
We have 3 different COVID vaccines, and we have a new strain in the vaccine that's new as of September of 2024 to be more current with the current strains that are circulating. It's nice to get them together, because if you, for instance, got your flu vaccine, then it's recommended that you wait 2 weeks before you get your COVID vaccine, and vice versa, because you'll start to have that immune response to the one vaccine that can interfere with the immune response to the second vaccine. So you want to get them together because then you're one and done, one appointment and done. But if for whatever reason you were unable to get them together, then you need to wait 2 weeks between to get the other shot.
Got
So
it.
that's why I recommend doing what you did and really getting them together.
I love the pharmacy feeling empowered.
Last year, I got my COVID booster and second Shingrix shot together. So you can get these different vaccines together. Be aware you may have a little bit more reactogenicity together. I don't know what your experience was. I do say to people, if you've had those where you feel, a little bit feverish, a little myalgia, a little muscle ache, fatigue, if you've had that with previous either flu shots or COVID shots, I do recommend that people take a Motrin or a Tylenol a couple hours after vaccination to help make that feel better. I do say one of the things that you're feeling really is your immune response kicking into gear and generating the protection that you're going to need for the vaccines. But I also say if you don't have any of that, don't worry. It doesn't mean your immune response isn't working. It's just people are very different and they react in different ways. But if the side effects are bothersome, it's okay. We generally recommend Tylenol over Motrin. But if you're in a bind, either one will do.
So I did have those exact symptoms that you just described for about a day and a half.
Mm-hmm.
And Tylenol became my new best friend. For about 48 hours. And then I was fine again. And I thought, oh, the vaccines are working. They're doing their job.
Exactly.
This is a good thing. The development of the RNA vaccine revolutionized the mechanism by which vaccines work. I do think, though, it has been very confusing to the general public regarding this, that they'll say, I don't think I want anything that has to do with RNA. I don't think I want that. I'm still befuddled why they keep saying that to me, particularly trying to set an example. Do you think I would purposefully do something to myself that would do harm to me? I am your poster child for vaccination compliance. And despite that, they still get it's RNA. I'm trying to flip that around for them, but I've really had great difficulty in doing so.
What I explain to people, so RNA is all over your body. That's your body's machinery. We use RNA to make all of the proteins in our body, all of the enzymes, everything that keeps our body running is based on RNA. RNA is very short-lived. It's very fragile. When we work, for instance, in the laboratory to make proteins, if we want to make proteins, you can make proteins from RNA. If we want to find out what an infection was, we can do PCR to look at different RNA and stuff. And the RNA is very, very fragile. And the RNA in these vaccines does not stick around long at all in your body. A few hours, maybe 12, at maximum 24 hours, and then it's gone. And that's good. It's also, though, I would say one of the things that we're looking at is we know that if that RNA, while it's there, it's producing that protein that's stimulating your immune response. And what we like about mRNA vaccines is that protein is being produced in your cells and being shown to your immune system the way the natural spike protein of COVID is. So you get an immune response very similar to a live attenuated vaccine response in terms of the breadth of that immune response, meaning that you're getting both the antibody response and you're getting some T cell response. Now, because the mRNA isn't around for very long, you don't get as strong an immune response as you would with a live attenuated vaccine. And people are looking at second generation mRNA vaccines to see if we can maybe get that protein production a bit longer to get a better immune response. But these mRNA vaccines are very safe. I think one of the advantageous things about them is that mRNA itself, the way it's presented to you, it's in what we call a lipid bubble. So it's in a protective envelope so that it's not destroyed before it can get to work in your cells. And that lipid bubble itself can stimulate the immune system, helping get a better immune response. The nice thing that I say about mRNA vaccines is that antigen is very targeted. You only have the sequence in that mRNA for that protein or for that antigen, whatever it is you're looking to produce an immune response for. The information, the data that we have around mRNA vaccines, these vaccines have been given now billions of doses. We know that they're safe. Safe doesn't mean that there's zero side effects. We have to really do a better job of communicating with people what to expect and what not to expect. Some people with these mRNA vaccines, particularly young adolescent boys and young men, have had some inflammation of the heart as a response to these mRNA vaccines. Now, that being said, we know that that age group in particular has a higher tendency to have myocarditis, which is that inflammation of the heart, to other things as well. We don't understand why that age group in particular, but we have associated it with mRNA vaccines. And that's why if somebody has had that reaction to an mRNA vaccine, it's recommended that they not receive another mRNA vaccine at this time.
What percentage of young men then?
It's really quite small. And it's really an age group when we look, it's like 15 to 30. We look at it more as you have an X-fold increased risk of myocarditis. Early on with the COVID vaccines, I believe with one of the vaccines, it was a 5 to 10-fold higher risk with that first mRNA vaccine dose compared with the second. So it was a substantial increase in risk for myocarditis. And it's recommended that, again, if that happened, that they not get an mRNA vaccine. But again, it's a relatively small percentage. The risk goes up. And even with that increased risk, not everybody, of course, gets it. But we do want to make people aware of that. We also, though, look and say, okay, what is your risk for COVID? And what is the risk of severe COVID, long COVID, all of that, and take that into consideration when we make recommendations about these vaccines for people who are a little bit uncertain about them. As I said, we have generated so much safety data with these mRNA vaccines. Billions of doses have been given. Reactogenicity, the most common side effects that we see are what I just described as fatigue, muscle ache, maybe a low-grade fever for 24 hours or so. With the Moderna vaccine, sometimes we see a red arm, a big red spot on the arm that's completely normal. It goes away. It's not harmful. Those are really the main side effects that we see with these vaccines. So not unusual, nothing unusual that we haven't seen with other vaccines. But they do, as I said, really do provide protection. What we've seen is protection against more severe COVID, protection against hospitalization, protection against long COVID. Now, we do recommend, for instance, if you've tested positive for COVID, that you wait about 3 months before you get vaccinated, because we don't want the immune response from your last COVID infection to affect the immune response to the vaccine. Again, we don't expect these vaccines to prevent infection. What we really want to do is change the severity of the disease and make sure that you don't get really sick from COVID. You may have some sniffles, a mild cold, but you're not going to be hospitalized. You're not going to die, and it's really going to reduce the risk of long COVID.
How often should someone be getting the COVID vaccine? What I've seen the pattern be so far is about every 6 months.
It's really going to depend on the circulation of COVID. And what we've seen since 2020 is that it's not going anywhere, right? We're seeing it circulating all year round. We really don't have a seasonality at all for COVID.
Right.
And then we're also seeing changing strains of COVID. And this is not unusual with cold viruses. If you think back to growing up, almost everybody had, they would call it a summer cold, or they would have 1 to 2 colds a year. COVID is a coronavirus. It's a cold virus, and it's spread through your nose, which means it's harder for a vaccine that's given in your arm to really prevent that infection of the nose, which is why we see not complete protection against infection with the vaccine or even natural immunity. We know if you've had COVID, you can get COVID again. What we look at is what's circulating, what's the vaccine, what's your risk, do you have comorbidities that put you at greater risk for more severe COVID? Then we generally do recommend, if it's circulating, then yes, you should get vaccinated. If that means about every 6 months, then that's completely appropriate.
So we've been talking a lot about proteins, and I want to make sure our listeners are not associating that with the protein that's in our diet. I heard someone say a few weeks ago, I have gone on a high protein diet so I don't have to get any vaccines. And I went, yoo-hoo, come over here and sit next to me. That's not how this works. But I can understand where there would be confusion because they do know about a protein diet, but we're talking about something quite different and not what we're actually eating. Could a patient request a blood test to see what their titer is, to measure their immunity level that they perhaps already have?
Well, unfortunately, you have to look at one what are they measuring those antibodies against? The virus is continually evolving. So even when we measure antibodies, and we don't know what antibody titer or what amount of antibody is protective. We don't know that. You could get a level. What that means, nobody knows. And that's why we tend not to recommend that. The other thing, as I said, is we use all of these commercial laboratory tests have to be really validated. And so they're generally validated. It may be even against the very first strain of COVID that was circulating. That may be totally irrelevant to the current strain of COVID circulating.
We've gone through many strains.
Yeah, they're generally not updated like that. So we tend not to recommend that because I don't find it particularly useful at all. And it may give you a false sense of security, with the keyword being false, because it may have absolutely no relevance to your susceptibility to the COVID strains that are out there.
One of your colleagues, Dr. Sabra Klein, studies vaccines specifically in women. To your knowledge, should gender influence the choice of the vaccines that are being given?
Well, that's a great question. In general, no. But what I will say is when we were evaluating COVID vaccines early on, before we had emergency use authorization for any of the vaccines, we were studying many different vaccines. And I was the principal investigator for the AstraZeneca COVID vaccine at Hopkins. And that was a different platform vaccine. So that was a vaccine where we used adenovirus as a vector, meaning we use that adenovirus, which is a common cold virus. This was not a human adenovirus. It was a chimpanzee adenovirus. But we used the virus and we put in the genetic material of the COVID spike protein so that that virus would show the spike protein to our immune system. What they saw in early clinical trials and rollout of that vaccine, because it was rolled out a little bit in Europe before it was approved here, is that women, particularly young women, about 25 to 45, were at risk for a very serious complication where they got blood clots, and many of them died. And so that vaccine was not recommended for women for that reason. We still don't understand really why that happened. We think that it's partially genetic. We certainly saw higher incidence, for instance, in Scandinavian populations than European, less common in US, and certainly far less common, if very few cases in Asian populations. But there was a difference between men and women, and certainly the myocarditis I described, we don't see in women. We saw in young men, but we did not see that in young women. So there are definitely differences based on sex. Now, in terms of response, we don't recommend one vaccine over the other for men or for women in terms of getting a better immune response or not. But we certainly do look at reactogenicity. And we know, for instance, that women tend to have more reactions to vaccines than do men. And we think that has something to do with sex and the fact that particularly young women, when they're pregnant, their immune system is different when they're pregnant and things like that. So there are definitely hormonal differences that can lead to different responses based on these vaccines.
Interesting. Before we close, I want to talk about some other vaccines that our listeners should be learning about and considering, whether it be for themselves or maybe even for their children or their grandchildren, starting with shingles. They've got some good commercials on television. I think they're great, that are designed to educate people about the importance of getting their shingles vaccine. The shingles vaccine is 2 doses. I've had the shingles vaccine actually a long time ago. What I have learned is that when I ask my friends, have you gotten the shingles vaccine? Well, I got the first one. Well, what happened to the second one? I didn't go back. Why didn't you go back? I don't know. I think it should be able to just be done in one shot. And I said, but it isn't. One of the friends said, well, I'm half covered. No, you're not. We don't know that. I haven't found any studies that have shown me that if you get one versus the 2 vaccines that you have half coverage versus, no, that's not how this works. We need to, again, educate people that there is a rationale behind getting dose 1 and dose 2, and anybody that's had chickenpox has the virus in their system. Now, my grandchildren are teenagers, and they saw one of these commercials that said, if you've had chickenpox, you already have the virus in your system. So they asked my daughter, they asked their mom and said, Mom, did you have chickenpox when you were a child? Oh, yes. Oh, my God. Then you could get the shingles, like a near death experience. Now, certainly is from a pain perspective, you kind of wish you could die. And I got shingles at the same time I got COVID. And I was trying to decide which one was worse, and I couldn't quite figure that out. But I do believe, and I may just be a Pollyanna with this, I do believe that the shingles was not as bad as it could have been had I not been vaccinated. That
Oh,
was how I
absolutely.
rationalized all of that. Whether I'm right or wrong, I don't know. But I did convince myself of that. And then, we've got college kids that are off to the university and other college campuses that are at risk of meningitis. I don't think that all school systems require it. I think they recommend it, but don't require it. I would rather them, frankly, require it. And then HPV, the vaccine for that we do know most of the time your body will clear that particular virus, but not 100%. There isn't a way to know that by looking at you. And this is the virus that has been proven to be certainly the primary cause of cervical cancer in women, and approximately 28% of men who get head and neck cancer. It's the HPV that has caused that. I don't know what the youngest age is. Is it like 11 that you can start your children vaccinated? And I think it now goes up to 40 something for the age
Yes.
group.
I think you can even get it starting at age 9. I mean, certainly when you want to
Okay.
get your child vaccinated is certainly before they become sexually active. And what's really nice there's a couple nice things about the HPV vaccine. First of all, it's one of the most effective vaccines we've ever had. It's incredibly effective. It reduces cervical cancer, I think, by close to 97% or something. It's an incredibly successful vaccine because it contains numerous different strains of HPV, certainly 16 and 18, the most common strains that cause cervical cancer, but also other strains that cause, as you said, head and neck cancer, anal cancer.
Mhm.
Originally, it was a 3-dose vaccine. Now they're looking at 2 doses, and WHO even is looking at a single-dose vaccine.
Oh, wonderful.
We need more data to see what the durability of that protective immune response is with the single dose. But it is an incredibly important vaccine to get because it reduces cervical cancer, head and neck cancer, anal cancers, and of course, genital warts. As I said, it's one of the most effective vaccines that we've had. So some of it is shared decision-making. So generally, if you're older than 25, then they'll do something called shared decision-making with your provider to say, are you at risk for more HPV disease? And if so, and generally that has to do with the number of sexual partners that you have and some other factors, then you should consider it. People will say, well, I already have genital warts. Should I get the HPV vaccine? And we say yes, because again, there's multiple strains of HPV that this vaccine is protecting against. If you've already been infected and currently are infected with one of the strains, the vaccine won't cure that. It's not what we call a therapeutic vaccine. It's a preventative vaccine, but it will prevent you from getting additional strains of HPV that are covered. People are working now to try to develop therapeutic vaccines for HPV, but we're not quite there yet. And
Should
then
women get a pap smear before getting the vaccine just to see how things are down there?
So I think a pap smear is always good because, again, whether you were vaccinated or not, and it doesn't cover every single strain that causes HPV. It covers most of them, but not every single one. So certainly I think that is important to still continue, even if you have been vaccinated. I did want to touch a little bit on shingles because I think the shingles vaccine, again, is a very important vaccine to get if you're 50 years of age or older, or we recommend it earlier, younger, if you have different conditions, if you're immunocompromised, if you're a person living with HIV, we recommend that you get it younger than 50 because although shingles, the acute shingles is bad and very painful, you can have long-term neuropathy and painful neuropathy as a complication of shingles, and you really want to avoid that. Again, the vaccine is very effective at prevention of long-term neuropathy as well as recurrence of shingles, and certainly mitigating the disease if it does reappear. So the shingles vaccine is very important. People will say it was painful. I felt really crappy after the first shot. That happens to a lot of people. Again, I recommend Tylenol. I've had both my shingles shots and I was knocked out for about 12 hours after my first one. But I feel so much better knowing that I'm protected against shingles,
Right.
because that is very
That's
painful
fair.
if you have it. And then you can have long-term, really debilitating neuropathy from shingles. So it's an important vaccine to get.
How about the pneumonia vaccine, particularly for senior citizens?
This is what I love. It's getting easier and easier. We used to have all this complicated algorithms with different pneumonia vaccines because there's different types of vaccines. There's one vaccine, Pneumovax, which has been around for a long time. It's just based on the sugar coating, I call it, the capsule, the sugar coating of the pneumococcus, and it covers 23 different strains of pneumococcus. Then we have pneumococcal vaccine that's part protein and part sugar coating. And that you get a much
Here comes that nutrition discussion again.
I know. We call it conjugated vaccine. And that gives you a much better, much long-lasting immune response. Because when the vaccine is made only of that sugar coating, it doesn't give you a memory response. Your immune system doesn't remember that it's seen that before. But with the protein, it does have a good memory response. The conjugated vaccines started with covering only 7 strains. Then we had 13, then we had 15. Now we're up to 20. So the recommendation, what I always say is if you are due for your pneumococcal vaccine, and generally it's everybody, if you're older than 65, if you have other comorbid conditions, if you have lung disease, if you have kidney disease, it's recommended that you get it sooner. But you can get the 20-valent vaccine one and done, which makes it so much easier. If you've had Pneumovax before, the sugar vaccine, then it's recommended that you wait about a year until you get the 20-valent conjugated vaccine. But then once you've gotten that, you're pretty much done. If you've gotten the 15-valent, then you need to talk with your doctor because it'll be recommended after about 5 years you get the 20-valents. But if you get the 20-valent to begin with, you're covered, which is great. Makes it so much simpler. The other vaccine that's recently come out for the elderly is the RSV vaccine. That was just approved last year for elderly people, particularly those with comorbid conditions or living in nursing home facilities, that sort of thing. We start with the single dose of the vaccine. There's 2 different vaccines that are available for the elderly, one made by Pfizer, one made by GSK. We don't know how long that protection lasts. So right now, it's recommended that you get your vaccine, a single dose. And for people who are healthy, younger than 65, healthy, no comorbid conditions, have a discussion with your physician because you may want to wait a little before you get that vaccine. Again, because we don't know how long that protection is going to last. We don't know if there's going to be a recommendation that you be revaccinated later. We don't know. It's only been out a year and we're following the data. Now, there is the Pfizer vaccine, RSV vaccine, recommended for pregnant women late in their, I think it's 32 to 36 weeks gestation between September and January. And that is, we're vaccinating the pregnant woman, so she'll make antibodies that will then be transferred to her baby to protect the baby after birth against RSV. The vaccine that's for the elderly, again, there's 2 different kinds. One is Pfizer, one is GSK. Again, that's only for the elderly. We don't have recommendations for RSV vaccination really outside of those age groups. Maybe for immunocompromised who may be at risk. One of the issues that we have is the immunocompromised don't respond really well. So solid organ transplants don't respond really well to these vaccines. So we're gathering more information to say, do we need to give them higher doses? Do we need to give them lower doses? That sort of thing. We're working on that. But I do recommend if you're 65 or older, talk to your doctor about whether or not you should be vaccinated against RSV. We're right now heading into RSV season, so now is the time.
I think it's also important, certainly our PCP needs to know when we have gotten these vaccines that he or she have recommended, but we also should be keeping track of this ourselves maintaining either printing out off of the internet, which is what CVS lets you do. You've been vaccinated, and here's the number and the date and the everything, which batch it was in and such. We all started off with COVID having vaccine cards, which I even have a little leather thing that I carry it in just for that purpose. But we also need to be mindful in knowing, well, when did I get that flu shot last year? Did I get the second shingle shot? Oh dear, when's that due? Because we need to assume some responsibility for taking care of ourselves and doing the right thing at the right time and not letting time go by for which then we end up not being protected.
We do. And now with the advent of electronic medical records, we all often can sign up for the portal. I love it because everybody refers to whatever medical record system your hospital, your doctor uses. We all go to the portal. We can look at our records. We can upload our vaccine records into that portal, and so that your physician is aware, and also you can check those records anytime. So it's a really good place to store all of your records once you figured out how to use your portal.
And that's what I did. I uploaded mine and my husband's into Hopkins MyChart, so our PCP would know we've done the right thing, and we'll continue, I believe, to continue to do the right thing. I am a strong believer in prevention. Whenever we can avoid an illness that can be, for some people, quite serious and can even lead to death, I'm all in favor of us taking care of that. So we've learned a lot from you today. For sure, Dr. Durbin, about the various vaccines and even how they're made and how they work. And I do hope that our listeners out there are being mindful now that we're entering the flu season to go to wherever is going to be the most accessible location, which could be your supermarket, and proceed in getting these vaccines. And as mentioned earlier, go ahead and do the flu and the COVID vaccine the same time, not in the same syringe, but at the same time. So you've already banged two of those out, and it's a good thing to combine them in that way. I want to first thank you, Dr. Durbin, for taking the time to speak with us about what is surely a timely issue. Now that we're starting the process of learning that so-and-so has COVID and so-and-so has the flu, and I hope everybody can smile and say, well, I've been vaccinated, I'm still going to be careful. It doesn't mean that I can't get sick, but I won't get as sick as that person I'm looking at who chose to decline the vaccines.
Exactly.
For those of you listening who live in Maryland, DC, or Northern Virginia, there is still time to register for the 30th anniversary of A Woman's Journey program that will be held on November 23rd at the Baltimore Marriott Waterfront Hotel. To learn more about the Johns Hopkins Medicine experts and their seminars that are being offered on that day, please visit hopkinsmedicine.org/A Woman's Journey. To all of our listeners, I look forward to next month when we bring you another education podcast featuring another Johns Hopkins Medicine expert. Take care, everyone.
Thank you.
Thank you for listening to A Woman's Journey podcast. Join me, Kelly Gear-Ripken, your host, Lily Shockney, and a variety of Johns Hopkins experts on the first Thursday of each month to learn about medical advances in women's health. A Woman's Journey acknowledges unrestricted educational support for our podcast, Healthy Insights That Matter, from Astellas. For more information about A Woman's Journey's virtual programs occurring throughout the year and our monthly webcasts and podcasts, visit our website, hopkinsmedicine.org/A Woman's Journey. Like us on Facebook and Twitter, and visit our website at hopkinsmedicine.org/A Woman's Journey. Until next time, stay well.